Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, my name is Fabil Huda from University of Riau, Indonesia. I would like to present our research is about leakage and blockage position detection in pipes using sound signal from a simple microphone and wavelet transform. As the introduction, pipes are vital infrastructural elements used to transfer gas, water, and other materials in daily life and business. Their seamless functioning is essential for several industrial processes and everyday activities. Maintaining the integrity and functionality of the pipe depends on detecting and differentiating the faults in pipe, so that research on damage detection in pipe is really essential. There are two types of damage that frequently found in pipeline. The first one is leakage and the second one is blockage. The leaks can cause resource waste, toxic gas emission, and water contamination, and blockage can prevent the delivery of materials, resulting in costly repairs and operating downtime. These two types of damage will be investigated in this research. Because of the importance of damage detection in pipe, several methods has been investigated. The very basic method is visual inspection, but this method has the weakness that the pipes that are easily accessible can only be inspected visually. The other methods are ultrasonic, vibration-based, acoustic reflectometry, flow monitoring method. These methods require complex and costly equipment. So the main issue is how to provide low-cost equipment for detecting damage in pipe. The method of sound signal or acoustic reflectometry method presents some benefits for pipeline damage identification. This technique sends acoustic pulses into the pipeline and analyzes the return signal to discover obstruction, leaks, and the other irregularities. Real-time monitoring, which enables from issue identification on localization without requiring significant excavation or physical access to the entire pipeline, is one of its main advantages. So in this research, the sound signal or acoustic reflectometry will be used to investigate damage in pipeline. By using low-cost microphone, we will investigate whether this method can detect the damage in pipeline accurately. The research method. At the first stage, we conduct finite element analysis of pipes. The study used ANSYS 2024 R2 to model and simulate the natural frequencies of a PVC pipeline, comparing normal, leaking, and block conditions. And here are some data of the pipe. By analyzing the natural frequency changes in different damage scenario, we will find the difference between normal, leaking, and blocking conditions. And here is the experimental setup. The speaker will give impulse into the pipe, and here is simple microphone positions. We install it in the pipe, and then the microphone connected to data acquisition, and data acquisition will connect it to the computer. And we give the leakage, some leakage and blockage in the pipe. And then the artificial failure condition is given to the pipe. The first form of damage in pipe is leak condition. In leak condition, we make some position of the hole to the pipe, and for the blockade condition, we put some plasticine in the pipe. Result and discussions. Here is the result of finite element analysis of pipe. We can see here comparison between natural frequency of pipe between normal and with leakage and the blockage. And the data from mode 1, the first mode, until the fifth mode. We can see here that by giving the leakage, the natural frequency of pipe is changed, and also with the blockage. This condition so that the damage will change the dynamic properties of the pipe in the end of the pipe. This is the cap of the pipe, and this is the result of normal pipe testing. We can see here time domain signal at the position of 0 is the position of the microphone, and the end of this data is the position of the cap of the pipe. So we can see here that at this position is the microphone position, and for normal condition we can see just a little bit curve here, and when we use wavelet transformation, we can see here the space, and we can look up to the position. With position, the wavelet coefficient is higher than the others. And this is the result of leak pipe testing. The hole or leak block, the block at the position of 1.1 meter from the microphone, the position of microphone here, and you can see time domain signal in some position we get the really high response here and here, and after that we can see some curl after the peak. So in wavelet transformation, we can see the really clear peak here. So the function of wavelet transformation is to make our data clearer, so we can take this peak as the position of damage or the position of the blockade exactly. And this is the result of leak and block pipe testing. So we give in one pipe two type of damage, the leakage in the position of 1.3 meters, and the block is given in the position of 0.8 meters. So you can see here, this is the position of blockage, and this is the position of leakage. And this is the comparison of result for normal, leakage, and blockade pipe testing. Just, the blue color is normal, the red color is leakage, and this cyan is blockage 3/4. So we can compare here. So normal is not so many curve, and for the leakage, 10 millimeter leakage, the red one, we can see the clear peak here, and for the blockage, we can see peak here, and after the peak, one wave. After that, we can find some curl, high curl, but not in leakage position. So the difference is after the blockage, we can find some high core, maybe some impact because of the blockage. And the conclusions: detecting pipe damage from leaks and blockage using sound signals from a simple microphone has been successful. Tests show that the wavelet characteristics and time domain signal features of normal pipe differ from those with leaks or blockage. Wavelet coefficient increase with larger leakages or blockages, and the wavelength at a leakage point is longer than at a blockage. Detection can also identify combined leaks and blockage. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.